Welcome back to What If. Today we'll be busting through the BS and sorting out the truth behind some of the biggest misconceptions and myths you've ever heard. We've got 3 stories that'll make you question everything you thought you knew about space, dinosaurs, and the universe itself. Think you know anything about black holes, stars, and planets? Well, you're wrong. We'll show you what's what as we bust through some of the biggest myths and leave you starstruck. Then, from feathered predators to colorful scales, dinosaurs might not be as Jurassic as Hollywood would have you believe. What secrets are these prehistoric creatures keeping? And finally, just when you think we've covered it all, we'll uncover even more cosmic misconceptions that might just blow your mind. Have you heard the stories around how Saturn's rings make it special, or how black holes suck in everything around them like some kind of galactic Hoover? Well, get ready for a reality check when we correct the lies you were told about space. When you think of ringed planets, well, you probably assume there's only one of them in our solar system, Saturn. But what if I told you that there are 3 other planets similar to Saturn? Yeah, it's true. Jupiter, Uranus, and Neptune all have their own sets of rings. Most people don't know about them because they're much thinner and pretty much invisible from Earth. We only learned about them when Voyager 1 and Voyager 2 flew past them in the 1970s and 80s. Some scientists even think that Earth had rings at some point in its existence. 4.5 billion years ago, when a planet the size of Mars smashed into our young rock, it ejected so much debris that it likely, briefly, formed a small ring around Earth. Despite their unimaginably massive gravitational pull, black holes don't go around sucking in everything in their way. It just doesn't work like that. Black holes are more like sinkholes. If you were to get too close to one, you'd get spaghettified and lost to the blackness of this monstrosity. But if you're far enough away from it, you'd be safe. Even if our sun was replaced in the middle of our solar system by a black hole with similar mass, all the planets would just orbit like nothing happened. Things would get pretty dark, though. Now, speaking of darkness, the moon doesn't have a dark side. Our planetary partner gets hit by the sunlight all around. The reason why you don't see the other side of the moon is because it's always facing away from us. Yeah, our moon rotates on its axis at the same rate it orbits Earth, making it what's called tidally locked to our planet. If a large asteroid is on a deadly collision course with Earth, the best thing to do is to nuke it. Oh, sorry, wait, I've actually got that wrong. Do not nuke asteroids that are about to collide with us. The reason why? Well, because the nuclear explosion will shatter the asteroid into millions of smaller pieces. Yeah, the pieces that would still be headed for impact with us. Instead of dealing with just one giant asteroid, we'd have to deal with multiple impacts. And it would make our evacuation really difficult, or straight up impossible. Now, you still can use a nuke to prevent an asteroid collision, but you don't even have to strike the space rock. We just set off a nuke near the asteroid. Emphasis on near. Then, the force from the blast would nudge it off course. That would keep our planet safe. Hopefully. Standing on Earth at night, you can see thousands of stars, but the view from the moon is actually quite boring. Yeah, astronauts who traveled to the moon reported that stars aren't easily visible from there. Because our moon is super reflective, it really cranks up the brightness, making it harder to see out to the stars. It's kind of like stargazing in a city with a lot of light pollution. Not fun. You'd need to travel further into space to get some better views. Traveling in space won't make you taller. Though it's true that astronauts can grow up to 5 centimeters in space, well, that's because the Earth's gravity doesn't weigh them down, and the vertebrae in their spines are able to expand a bit. But this effect is only temporary. As soon as you return to Earth, you get back to your regular height. Yeah, thanks, gravity. And space travel doesn't make you age slower either. Not really. Albert Einstein theorized that time would pass slower for someone traveling at high speeds versus for someone stationary. This is called time dilation. And while it's true, you'd have to travel incredibly fast to achieve this de-aging effect, like almost speed of light fast. Yeah, with our current space traveling technology, the difference in time is so minimal that it's not even worth calculating. If you thought crying in space was impossible, well, first, why? And second, you're wrong. It's just different. Without gravity to pull your tears down, they don't trickle down your face like they do here on Earth. The tears just stick to your eyes and form a sort of watery blob. They might even cover your eyes if you cry a lot, so while you can totally cry in space, it's probably best that you don't. Not great for visibility. Hey, Martian dust storms are a real headache. The dust particles are so fine that they can get anywhere, and these dust storms can last for months, but they can't physically damage any equipment that we leave on the red planet. The thing is that the Martian atmosphere is super thin, just about 1% of the atmosphere we have on Earth, so even when these dust particles zoom around at about 100 kilometers per hour, they can't pack a big punch without the help of air. But what they can do is cover our solar panels and put our rovers into power-saving hibernation. Oh, and I wouldn't inhale this dust either. Who knows what this fine powder could do to your lungs long term? Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, this song is a big fat lie. Yeah, despite the famous children's song, stars don't twinkle. The flickering is just an illusion. Their light is actually very steady. Stars appear to twinkle due to the gas molecules that make up our atmosphere. They deflect some of the light from stars, making them appear as if they're shimmering. Asteroid belts are typically depicted as minefields of floating rocks. Spaceships have to weave in and out of the asteroids in a life-or-death situation, but in reality, our asteroid belts are nothing like what you see in the movies. Asteroids aren't that close together. In fact, they're extremely far apart. For example, in the asteroid belt between Jupiter and Mars, each of the asteroids is several million kilometers away from their nearest neighbor. And the chances of a collision are about 1 in 1 billion. So while Han, Chewie, and Leia had you on the edge of your seat in The Empire Strikes Back, asteroid fields like that are far from reality. The Great Wall of China is known to be the only man-made object that's visible from space. But this is entirely false. Yeah, sure, maybe you could see it with a camera and a zoom lens, but it's almost invisible to the naked eye. At 5 to 10 meters wide, the wall is way too thin to be seen from space. However, you can still see plenty of other man-made objects from space. Things like dams, bridges, and pyramids. And at night, you can see a light show from the world's big cities. Well, that was out of this world. Sorry. But from discovering other ringed planets to learning why nuking an asteroid might not be such a great idea, it's fair to say space is full of surprises. Maybe it's time to fact-check the whole solar system. Now, let's hop in the DeLorean and head back in time to answer some more big questions. You know, like, did dinosaurs really look like they do in the movies? Were some of them more bird-like than beastly? Well, prepare for a prehistoric revelation. The things you were lied to about dinosaurs. You might have heard that all dinosaurs were wiped out 65 million years ago when a 15-kilometer wide asteroid crashed into Earth and caused a mass extinction event. But that is entirely false. One species of dinosaur, theropods, managed to survive. They had feathers and hollow bones, and most of them could fly, meaning they could rise above the blast and survive the aftermath. And now, many scientists believe that these theropod dinosaurs managed to evolve into birds. So technically, dinosaurs are still alive and with us today. But that's not the only thing you were lied to about dinosaurs. From non-existent species to T-Rex's eyesight, there are many myths and misconceptions about the Mesozoic era. One of the craziest is that dinosaurs were all green, scary monsters. In fact, many of them likely had feathers. Theropods would have had feathers for a variety of reasons, from giving them warmth to helping some aviation-based dinos to fly. And that's not all. Dinosaurs were a variety of colors. Yeah, some fossils have preserved pigments, showing that not all dinosaurs were brown, black, or green. They may have had many vibrant colors. Some of them may even have had specific camouflage, depending on their environment. And they weren't all scaly and slimy either. Different dino species would have different textures to their skin. I want to know if any of them were fluffy. Now, when you think of dinosaurs, you probably think that they were all massive. The T-Rex had a length of 12 meters, and the long-necked Brachiosaurus was up to 13 meters tall. But that wasn't the case for all dinosaurs. Contrary to popular belief, not all dinosaurs were giants. In fact, many of them were pretty small. Some were even the size of birds that we have today. Look at that one. One small dinosaur was the Microraptor. This little guy was about the size of a crow. He even had wings and feathers, making him look like a bird. Dinos are typically portrayed as slow-moving, cold-blooded reptiles, but this isn't totally accurate. Scientists have recently discovered that dinosaurs weren't all cold-blooded like we thought. But that doesn't mean that they were all warm-blooded. It's a bit more complicated. Dinosaurs may have had a metabolic system known as mesothermic. This means they were somewhere between cold and warm-blooded. Being mesothermic allows animals to generate some internal heat, just not as much as a warm-blooded animal would. Dinosaurs with feathers may have been warm-blooded. Feathers usually suggest warm-blooded. Now, of course, there were thousands of species of dinosaurs, so sure, many of them may have been cold-blooded, but there were also warm-blooded and mesothermic dinosaurs. The Brontosaurus is one of the most iconic dinosaurs ever. With its long neck and tail, it's probably one of the first dinosaurs you think of. But did you know that these creatures almost didn't exist? Yeah, in the 19th century, the Brontosaurus was accidentally classified as the Apatosaurus, a species with similar traits. It wasn't until 2015, after years of research, that the Brontosaurus was reclassified as its own dinosaur. Kind of like how Pluto comes and goes as a planet, the dinosaur community seems to have some sort of trouble making up their mind on the validity of the name Brontosaurus. Movies like Jurassic Park often show the Tyrannosaurus Rex as one of the most deadly predators, destroying everything in its path. The only catch? They can only see prey if it moves. Yeah, that's also completely false. To make the T-Rex even more terrifying, they had incredible vision and were easily able to see prey that stood still. Since the T-Rex's eyes were positioned forward on its head, it had binocular vision. It could easily judge distances and see objects in 3 dimensions, similar to how humans see. Research suggests that the T-Rex might have had better eyesight than modern-day birds because it had such large optic nerves. It's easy to forget, but dinosaurs didn't all live simultaneously. The Mesozoic era, also known as the Age of Dinosaurs, spanned over 180 million years. There were three distinct periods: Triassic, Jurassic, and Cretaceous. And within these three periods, different species were unique to the specific era. Within 180 million years, some dinosaurs evolved into new forms, and some species went extinct. Some of the most iconic dinosaurs, like the Stegosaurus and T-Rex, never actually coexisted. They lived in entirely different time periods, tens of millions of years apart. Also, the T-Rex is often shown as a Godzilla-like creature that can stand upright, but how accurate is this? Well, turns out it's a total misconception based on early artists' renderings. Paleontologists have since found that the T-Rex had a more horizontal posture. Its tail was held up off the ground, and its body was balanced over the hips. The upright stance of the T-Rex that we typically see is fun for Hollywood, but it would be unstable and impractical for the dinosaur to move around freely. When fossils are dug up, the shrink wrap method is often used to portray how the dinosaurs looked. This is where the skin and features are drawn tightly against the skeleton. The technique has led to some iconic dinosaur portrayals, but is incredibly inaccurate when it comes to how these dinosaurs actually looked. The problem is that it doesn't account for any muscles, fat, or any other soft tissues that the dinosaur had. Luckily, this method is considered outdated. Paleontologists now account for the muscles and the fat that the dinosaurs were likely packing on. They make comparisons with modern animals to find where muscle would typically be attached to the bone. This has led to a more realistic appearance for the dinosaurs. Paleontologists have identified over 1,000 different species of dinosaurs, but there are tons more left to discover. Literally. The numbers vary, but some research suggests we've only found about 30% of dinosaur species. And some we may never find due to gaps in the fossil record. Depending on where a species lived, they may have never been fossilized due to their environment. But many more will be discovered. On average, paleontologists discover about 50 new dinosaur species every year. Dinosaurs probably didn't sound anything like this. In fact, we really have no idea what they sounded like. Fossilization rarely preserves the soft tissues like vocal cords, and that makes it challenging for paleontologists to determine the exact sounds dinosaurs made. But it's unlikely they made these massive roars. Scientists can make an educated guess that dinos sounded closer to birds and crocodiles, since they're the closest living relatives of dinosaurs. Researchers have created models based on fossilized skulls. The models suggest that the dinosaurs may have made low-frequency rumbles or bird-like calls. Regardless of what they sounded like exactly, the scientific community agrees that they didn't sound like this. So, is it possible that one day we'll be able to clone dinosaur DNA and build our very own Jurassic Park? Well, as cool as that may be, it's never gonna happen. Since DNA degrades over time, the chance of finding intact dino DNA is, well, basically zero. And even if some were found, extracting the DNA without any contamination or deterioration would be incredibly difficult. Now, what if the DNA was preserved in amber, similar to the movie? Well, that's also highly unlikely, since DNA can't survive for tens of millions of years inside of amber. Yeah, I bet you never expected that dinosaurs were so much more colorful and fluffy than we ever imagined. Between the tiny crow-sized microraptors and the big misunderstood brontosaurus, turns out everyone's favorite prehistoric creatures had a lot more going on than Hollywood knows. Maybe it's time for a Jurassic reboot with some feathered flair. But before we start sketching out our new dinosaur storyboards, let's blast back into orbit. We've got more cosmic misconceptions to straighten out. Like, is Mercury hot or not? And is space always silent, or do they sometimes really crank it up out there? Let's break down a few more things you were lied to about space. Our sun looks nothing like this. It looks more like this. If you've always thought our sun was a bright yellow ball of fire, you were wrong. For starters, it's not yellow, it's green. Sort of. Scientists determine the temperature of a star by the color spectrum it emits. Each color has its own wavelength, and astronomers measure those wavelengths to tell how hot a star is. Cooler stars appear red, the hottest of the stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it also emits other wavelengths, all these colors mix together, and your eyes see this vibrant mixture as white. That is, if you look at the sun from the International Space Station. From here on Earth, the sun looks yellow because our atmosphere is really good at scattering blue light. And with all that blue wavelength gone, all the other colors combine into yellow. If our star was actually yellow, it would be about 800 degrees Celsius cooler, our solar system's habitable zone would shrink, and Earth would become a frozen, lifeless rock. But that's not the only thing you were wrong about. The sun is hot, but it's not on fire. Burning is a chemical reaction of oxygen with fuel. Like most stars out there, our sun is a ball of gas, mostly made up of hydrogen and helium. It doesn't have much oxygen in it. Instead, it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy, and that's why the sun is so scorching hot. Speaking of setting things on fire, let me tell you about explosions in space. Yeah, these aren't real. A spaceship can't go down in a violent blast because there's no air out there in space. No air means no oxygen, and no oxygen, well, as you already know, means no fire. Sorry, Star Wars fans. It may seem that there are too many stars in the night sky for you to count, but actually, you can. Although scientists at Harvard have already done it for you. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the naked eye. Try to count them all for yourself. Movies make it look like you need to be an extremely skilled pilot to navigate the asteroid belt, but that's not true. The asteroid belt isn't some thick obstacle course of death. It does have trillions of space rocks that range in size from space dust to a quarter the size of the moon. About 100,000 of these asteroids are over 1 kilometer wide, but they're very spread out. The asteroid belt between Mars and Jupiter is 225 million kilometers across. That's 1.5 times the distance between Earth and the Sun. And this spreads the space rocks millions of kilometers apart. It's almost impossible for a spacecraft to collide with one. If you were thrown out of the airlock into the vastness of space, you wouldn't turn into a popsicle right away. That's because to freeze, there has to be a heat transfer from space to your body. But heat, or cold, doesn't travel very fast in the vacuum of space. Your body would freeze, but it would take hours to happen. And by then, you'd be long dead from something else. And no, you wouldn't explode in space either. You would inflate, though. That's because nitrogen in your bloodstream would gather into bubbles and puff you up to double your size. But that's not what's going to kill you. It's the lack of oxygen. After 15 seconds in space, your brain wouldn't get enough oxygen through your blood, and you'd lose consciousness. After 2 minutes in space, your other organs would start to shut down one by one. Game over. Space seems incredibly cold, but it's not. In reality, space doesn't have a temperature at all. Temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around. That's why the vacuum is temperatureless. Of course, outer space isn't a perfect vacuum. It still has particles and radiation to produce heat. Some areas of space are actually really hot, like the space around stars. But the further away you get from stars, the more spread out the particles are, making those areas of space pretty chilly. Some dense gas clouds can get as cold as minus 263 degrees Celsius. Mercury is the closest planet to the Sun, but surprisingly, it's not the hottest. It is extreme, though. During the day, the surface temperature reaches 430 degrees. And at night, it drops to minus 180. Oof! But the most hellish planet in the solar system is Venus. You see, Mercury doesn't have an atmosphere to retain all that heat from the Sun. The Venusian atmosphere, on the other hand, is very thick and it creates a greenhouse effect. It's like global warming on steroids. And it makes Venus a hot hell with a surface temperature of about 475 degrees. Our entire solar system isn't just sitting in one spot in our galaxy. It's hurtling through space at 220 kilometers per second. That's 7 times faster than the speed that Earth revolves around the Sun. Our solar system takes 230 million years to make one orbit around the Milky Way. Yeah, the last time we were in the same location we are now, Earth had one supercontinent and the dinosaurs were just starting to roam around. Planets do not orbit around the Sun. All the things in our solar system are in balance, and even though the Sun is the most massive object in our planetary neighborhood, other planets are participating in this gravitational tug-of-war. Instead of orbiting the Sun, planets and moons orbit around a central point between them and our star. This point is called the barycenter. For Earth, this barycenter is so close to the Sun's core that there's not much of a difference, but for Jupiter, this point is about 55,000 kilometers away from the center of the Sun. So the gas giant and the Sun are orbiting each other. Earth appears round from space, but it's actually an irregularly shaped ellipsoid. It bulges at the equator thanks to the centrifugal force caused by our planet's spin. As a result, Earth is about 43 kilometers wider at the equator than it is at the poles. This makes gravity at the bulge slightly weaker, making it easier to launch spaceships from the equatorial regions than from the poles. In space, no one can hear you scream. That's only true to a point. Sound needs a medium to travel through, and in space, molecules are very far apart, so the sound fades away before it can get very far. All the cosmic catastrophes, supernovas, and colliding black holes go quiet before you can hear them. But some places in space have a lot of particles for sound to travel through. Like the hot gas cloud around the black hole at the center of the Perseus galaxy cluster. It has so much gas that you can actually hear the black hole. This is what it sounds like. Okay, that's it for another stellar journey through the cosmos. Discovering why Venus is hotter than Mercury and learning that stars don't actually twinkle make it clear that space is full of surprises. 13.8 billion years ago, the entire universe emerged from one single point in space. This theory is known as the Big Bang, and it's the most widely accepted story of the creation of our universe. Scientists came up with this universal origin story when they observed that every single galaxy in space is moving away from us, even today. That means that at one point in time, everything could have been condensed into an infinitely dense spot known as a singularity. This singularity was really hot, too. Other evidence of the Big Bang is something known as cosmic microwave background. It's radioactive telescope. But what if we have this all wrong? What if the universe didn't start like this? What else were we wrong about? This is What If, and here's what would happen if everything you knew about the universe is wrong. I'm sure you're not looking forward to the end of the universe, but glancing at its future demise could flip your understanding of the universe and its origins. Okay, so you know that our universe is continually expanding outward, so you might assume that it would likely continue expanding forever. Well, this could be true, and this is why the most widely accepted theory involves the universe doing just that. It's called the Big Freeze. And what's really cool about this is a mysterious and invisible force that makes the universe expand. It's called dark energy, and it makes up 69% of the universe's mass. Another 26% of it is made of dark matter, and only 5% of the universe is plain old ordinary matter. If all this material originated from one point and just kept expanding, eventually all this heat and energy would be very, very spread out. At a certain point, everything would be so far away from each other that the entire universe would reach a ridiculously frigid temperature. Absolute zero. Absolute zero is the lowest temperature possible. It translates into 0 Kelvin, or if you prefer a more familiar temperature scale, minus 273 degrees Celsius. By the time the universe reaches this super low temperature, you wouldn't be able to see any distant galaxies from your vantage point in the Milky Way. Don't worry though, that would be at least a couple of trillion years from now. Now, that's just one theory. It's also possible that the death of the universe will be the exact opposite of this. Instead of expanding forever, the universe could shrink back together. Time for the big crunch. All of the matter in the universe, taken as a whole, has an unimaginable amount of gravity. It might be enough gravitational force to battle the mysterious dark energy and win. If this big crunch were to happen, the universe would start to contract in on itself. Galaxy clusters far away would merge. Eventually, stars and planets in our own galactic neighborhood would clump together too. And this increasing density would heat up the whole universe. All that cosmic microwave background radiation from the Big Bang would get so heated that it would be hotter than stars. We're talking 5,000 degrees Celsius hot. The universe would become a scorching, chaotic mess. As temperatures continued to rise and more mass got crushed into a teeny tiny region, atoms would start to break apart. The universe would be turning into the densest black hole possible. While that would certainly be the end of the universe as we know it, it might just be the beginning of a new one. And that would be proof that our universe is much, much older than we thought. The universe may have formed itself over and over again. In this violent cycle of contraction and expansion, you wouldn't have the slightest chance of surviving to witness this epic event firsthand. No one would. So for now, all of this is just an end of times theory. And it has a big name, the Big Bounce. It suggests that the universe expands and contracts all the time, just like a lung that breathes in and out, only in slow motion. And not just once or twice. According to this theory, there may have been billions, trillions, or even an infinite number of universes, both before and after ours. Each time the universe reforms, it could create completely different laws of physics. This would create all kinds of strange possibilities. There could be universes with no life, no stars, and not even an atom in sight. Now, this is all pretty wild, and it gets wilder from here. Some scientists debate that everything we know about our universe is wrong. What we know about the cosmos is based on what we can see and study in our galactic neighborhood. Then, we assume that it works like that everywhere else in the universe. The idea is old, and it's called the cosmological principle. But we may have been wrong all along. It could be that the way our Milky Way galaxy moves through the universe is distorting our data. I mean, we've never had any hard evidence to confirm our theories, so there's no way of seeing the bigger picture from where we stand. This is where you could be starting to doubt whether any of this is real to begin with. Surely our universe, the one we can see, must exist, right? Well, not so fast. You have quantum mechanics to thank for what I'm going to tell you next. Scientists who study quantum mechanics theorize about the nature of the universe on an atomic level. And according to some scholars in this field, the universe must be one of two things: real or local. Bear with me here. I know this can be mind-numbing. If the universe is real, that would mean that it has specific properties like color and mass that exist even when you're not looking at them. For example, take a red ball. If it's real, the ball is red even when there's no one around to look at it. On the other hand, the universe could be local. This means that the universe can only exist because we are there to observe it through our telescopes. So if you think about the red ball again, without anyone around to observe it, it could have any color or no color at all. Only when you look at it and see that it's red, does it actually become red. That's quantum physics 101. But there's a catch. The universe could be either real or local. It can't be both. And remember that the universe is ridiculously big. It could be infinite. Our telescopes just aren't powerful enough to observe all of it. So that means we can't know for sure if the universe is even real. Whoa, you didn't see that coming, did you? Well, that should be enough of a head-scratcher to keep you pondering about how everything really came to be, where it all could eventually go, and what's the meaning of it all anyway? But before we get to that, do you want more What If? Well, then you should check out the What If Explorers Club over on Patreon. For just a couple bucks a month, you can get access to exclusive videos, ad-free episodes, and behind-the-scenes content, and more. We also have a private Discord where you can pitch your what-if ideas. So if you want more content like this and you want to give your support so we can keep making the best content possible, then become an explorer today. What if there are other universes just like ours, with an infinite number of Earths, with uncountable versions of you? And what if we don't have to look too far to find them? Maybe a mirror version of our reality is right here. This is What If, and here's what would happen if we could open a portal to a parallel universe. Our universe began when a small but very hot singularity exploded in the Big Bang 13.7 billion years ago. But maybe it wasn't the only one to be born then. In physics, space and time fuse into one four-dimensional continuum, space-time. If this space-time is flat and stretches far beyond the limits of our observation, there is a possibility that it holds uncountable, disconnected universes. But for all we know, there are a limited number of ways the particles in those other universes can be put together. At some point, the realities will have to start repeating themselves. That means, in theory, our reality is only a small part of what's out there. And someone just like you might be living in a parallel universe similar to our own. And that universe may be as close as a million trillion trillionth of a centimeter away. Although the wall between the universes might be incredibly small, traveling between them won't be easy, but it could be done. All you'd need is an 85 megawatt nuclear reactor capable of firing billions of neutrons on command. That's how a team of physicists working in Tennessee's Oak Ridge Laboratory are trying to open the gates of a mirror universe. Of course, they have to find it first. It all comes from a theory that says if you beam neutrons at a wall, none should pass through. If some do manage to make it to the other side, it would mean that they've transformed into mirror images of themselves as they went through the wall between the two worlds. How do we even know all that? Well, there's one odd thing about neutrons. In particle beams, on average, they last for 14 minutes and 48 seconds before they decay into protons. But if you place neutrons in a lab bottle, they'll break down 10 seconds faster. It's not something we can explain with physics yet. Neutrons are all the same, and there shouldn't be any 10-second difference in their lifespan, regardless of where they're stored. Could it be possible that the neutron experiments didn't go as expected because physicists accidentally opened a portal to a mirror world? That would be the first evidence that a mirror universe exists right next to our own. A mirror world with mirror atoms. Maybe even a mirror Earth. An entire mirror world, almost totally cut off from ours. Could you meet another version of yourself in that mirror world? Now, it gets a little complicated. Even though particle configurations can repeat themselves, the odds of finding a portal to a parallel universe that's exactly the same as ours are close to zero. Think about it. There are a novum vigintillion particles in the universe. That's the number 1 followed by 90 zeros. Every single one of them would need to have had the same interactions for 13.7 billion years to create an identical universe to what we have now. The mirror universe would most likely have its own mirror laws of physics, but it's hard to know for sure because nobody has detected a single mirror particle yet. Maybe we shouldn't be searching for answers in a lab. Perhaps we should be looking in space itself. Our universe is full of dark matter. We can't observe it directly, and we have no idea what it's made of or how it works, but we know that dark matter is strong enough to stop galaxies from flying apart. Yet, we can't find it. Perhaps the reason is that dark matter is leaking from a mirror world into ours. If we could detect that, it would confirm that a mirror universe exists. Because we know that there's 5 times more dark matter than there is visible matter in the universe, you've got to think that a mirror universe is much more massive than the one we live in. Even if we did manage to open up a gate into another world, the portal would be incredibly small. Too small for you to see anything without some very powerful lab equipment. We'd still be dealing with neutrons and protons, remember? You could only enter that realm if you had the ability to shrink yourself to the size of an atom. This pretzel-shaped collection of galaxies is our universe. And it's about to collide with another universe. It might be fascinating to watch, but we should probably be worried about what's going to happen when they crash. How would it change the physics of our universe? Is there any chance that we would survive? What would the collision look like from Earth? And has it ever happened before? This is What If? And here's what would happen if our universe collided with another one. The only potential evidence of a universal collision that we've ever discovered is in the form of a cold spot in our universe. In 2013, the European Space Agency's Planck satellite confirmed that this area is 1.8 billion light-years across. It's much colder than the rest of space, and it seems to be missing 10,000 galaxies. At first, scientists were baffled by its existence, but now some have theorized that this spot might be a kind of scar or bruise left from colliding with another universe. But how can we know for sure? And if this is the case, how long before it happens again? Before we go any further, let me take a second to address something that might have some of you scratching your heads. Usually, when we refer to the universe, we're talking about all space and time, including planets, stars, galaxies, and all other forms of matter and energy. So, if the universe basically means everything in existence, then logically there can only be one of them, right? Not necessarily. Some scientists believe in the concept of the multiverse. This theory states that our universe wasn't the only one that popped into existence during the Big Bang. That there's an infinite number of other universes out there too, and we just haven't found a way to see or measure them yet. If this theory is right, then it's possible that all these other universes could have grown at the same rate, at the same time, after the Big Bang. If that's the case, then they might have banged into each other as they expanded. And that brings us back to the cold spot. The cold spot is a region of our universe that's 0.00015 degrees colder than everywhere else. That might not seem like a big deal, but when the rest of the universe's temperature is so consistent, scientists have started to think it's something more than an anomaly. They think that the cold spot might be a scar left over from a collision between universes. And the crash might have moved a bit of energy out of that spot in our universe, causing the colder temperature. But what would a collision of that magnitude look like? Well, we can't say for sure, but there are some pretty cool ideas out there. According to one physicist at the University of California, if another universe came crashing into ours, it would look like a giant mirror in the sky rushing towards us, because its wall would reflect light. If this other universe collided with our own, we could inherit a whole new set of governing laws of physics. Gravity could weaken or disappear, resulting in a slew of planets escaping the gravity of their stars, sending them flying off into space at ridiculous speeds. Without gravity, stars would cease to exist, and we'd be left in perpetual darkness. This would make life on Earth, and throughout most of the universe, nearly impossible. With no shining stars, we'd lose any means of nourishment or breathable air, as plants would no longer be capable of transforming starlight into energy through photosynthesis. But as bad as that all sounds, it's not something we really have to worry about, since the chances of our universe colliding with another one are slim to none. For one thing, we're not even sure that there are other universes out there to collide with. And even if there are, any collisions would have happened at that point when they were expanding, 380,000 years after the Big Bang, which would mean there's little to no chance of it happening again. This is our universe, an ever-expanding network of stars and galaxies. And this is your brain. Don't they look eerily similar to one another? Why are they so alike? Could your brain be a mini version of the cosmos? Or could the universe actually be part of some larger consciousness? This is What If, and here's what would happen if the universe is conscious. Your brain is made up of neurons. These are cells that process information and signals throughout your body. Between these neurons is an underlying network of connections that allows them to communicate with each other. And on the largest scale imaginable, the galaxies in our universe form clusters with vast amounts of empty space in between. These clusters are connected to each other by a complex network known as cosmic webs. The universe and your brain. Puzzling, isn't it? Well, maybe our universe is a lot more complex than we thought. It might just be some sort of giant brain. Now, you could be thinking, wow, What If has really gone off the rails with this episode. This guy's crazy. But we're not the only ones to notice the similarities between galaxies in the cosmos and neurons in the human brain. Astrophysicists and neurosurgeons have been studying these networks, and they've found that the cosmos looks very similar to your brain, just on a much larger scale. Your brain is 77% water, and the cosmic web is about 73% dark energy. There are around 69 billion neurons in your brain, and the cosmic web could connect at least 100 billion galaxies. Not exactly the same, but not too far off either. Wait, there's more. Neurons and galaxies both share a similar pattern. 2.5 millimeters of your brain looks like 500 million light years of space. Pretty cool, right? Well, even that isn't all. Each neuron of that 2.5 millimeters of your brain connects to about 5 other neurons. And in space, each galaxy has about 4 different connections. Your brain and the cosmos aren't identical, but they are similar enough for you to ask this: is the universe a giant brain? Could it have its own consciousness? Theoretically, the universe could achieve consciousness, but only if it managed to understand its position in space and time. Then, it would need to understand how it relates to other things, like you. Have I blown your mind yet? Now, the universe isn't exactly like your brain. It's a lot harder for it to exchange information between the galaxies. It might be conscious, but on a level we don't yet understand. And how could we understand the consciousness of our universe if we don't even fully know what consciousness is and how it works? What we do know is that your own consciousness is pretty advanced, all thanks to your ability to understand what the future is. Humans are one of the few animals that think about tomorrow, at least as far as we know. What if your reality was nothing more than a complex computer simulation? How would you know? What kind of technology could make this simulation possible? And how could you break out of the matrix? This is What If, and here's what would happen if you were living in a simulation. This is what the very first computer games looked like. And this is what they've come to look like after some 50 years of technological progress. Today, it only takes a virtual reality headset to jump into a computer-simulated realm. Our future computers may be able to generate entire simulated universes. And if we humans were able to simulate complex realities, how could we ever be sure that our own world wasn't just a computer simulation designed by another, more advanced civilization? Everything in the world we live in seems to be based on mathematical laws. Even our genetic code has a mathematical model. Just like if someone had programmed our reality with a computer code. See where I'm going with this? We may be living in a giant video game without realizing it. But who designed this matrix? An advanced alien civilization? Maybe not aliens, but a future iteration of humanity simulating the lives of their ancestors, which would make you a living memory of someone else's great-great-great-grandmother. This future humanity would require extremely powerful supercomputers to run the simulation down to the subatomic level, much more powerful than the most advanced supercomputer we could imagine. If we ever got to this level of technological advancement and started running computer simulations of our own, that would be very strong evidence that our reality was also simulated. A simulation creating their own simulation. Chances are our creators would turn out to be someone else's simulation. In the many simulations from the original reality on down, each subsequent simulation would turn out less and less advanced. They just wouldn't be able to match their creators in advancing their technologies. If your life was a simulation, you wouldn't know, just like there's no proof that you're not living in a simulation, but you could try looking for the glitches. If our world was some computer code, it could have software bugs. Every now and then, when our simulators decided to roll an update, something could slip sideways. It could be a glitch like meeting your doppelganger, someone who looks like you but isn't related to you. It might just be a mix-up in character appearance preferences. If we ever found out that we were a program on someone's hard drive, it could be because that someone wanted us to. In that case, escaping the simulation would be, well, simulated. We'd just end up on another level of the matrix. Maybe discovering the identity of our creators would make them reboot the system. A big Control-Alt-Delete for the entire universe. What if the universe is an illusion? What if your reality is not what it seems to be? What if you are just a two-dimensional projection stretched on the surface of a black hole? And what does a black hole have to do with all this? This is What If, and here's what would happen if you lived inside a hologram. I know what you think. This isn't real. How can we live in a hologram if everything around us is three-dimensional? Well, prepare yourself for a big reality check, because this unified theory can explain everything about the fundamental laws of our existence. The holographic principle. We talked about it a little in the episode where a black hole deleted the universe. You may want to watch that one again. Because of all places, the holographic principle starts in a black hole. When you eat, say, a bagel, your mass increases by the mass of that bagel. With your mass increased, your volume grows, and so does your surface area. For a black hole, it's different. It's only the surface area and not the volume that increases with every bite. It's like the swallowed matter or energy doesn't make it inside the black hole, but rather gets stuck to its surface. Or like if you, instead of eating the bagel, just taped it to the outside of your stomach. Black holes themselves are three-dimensional, but their contents can be projected on their two-dimensional surface. And that gave scientists the idea of the holographic world. You, me, and everything else in the universe is made up of atoms and molecules. atoms and molecules are made up of smaller subatomic particles. And those particles, in turn, are made up of something even smaller: the information about their state in time and in space. These particles are so small that our eyes can't detect them. We just know they're there. And we know they don't answer to the classical laws of physics. It's up to quantum mechanics to interpret their nature. One of the ways to understand the smallest fundamental particles is through the string theory. The string theory is purely theoretical, and the mathematics behind it is complicated. Nobody has ever solved it yet, but maybe we can change the rules a little bit. If you're trying to solve a complicated problem, you can map all the volume of the universe across its boundary, like a hologram. The nature of the problem changes because for the two-dimensional universe, we don't need to count quantum gravity in. That turns the nearly impossible to crack mathematics of the string theory to maybe doable equations. It's not a solution yet, just a shortcut to the solution. But once you figure out how to solve it, you can transform the solution into our three-dimensional space. Congratulations! You solved the mystery of the universe and how it started, through the hologram. But does that mean we ourselves are living inside a hologram? And what would it be like to be a hologram? When you take a selfie, you lose some of the information about yourself. When you later look at the picture, you can't see the back of your head. The holograms are designed to preserve all of that information. If you experienced the world in a holographic way, you could look at someone else's skin and tell everything about their organs, what they ate for lunch, even their thoughts. Is it just me or does that sound creepy? The fundamental laws of our universe, from black holes to the smallest particles to the laws of our reality, could be potentially described with the help of the holographic principle. It doesn't necessarily mean we live inside a hologram, but if we did, we wouldn't be able to tell the difference anyway. The edges of our universe. But it won't be as simple as traveling through space, because the edges that we're talking about aren't in space. They're in time. Why is the universe that we see a universe of the past? How far back into the universe's history could you go? And what would you see in the young universe? This is What If, and here's what would happen if Earth teleported to the edge of the universe. The universe doesn't have the kind of edge you might imagine, but there is a limit to how far into outer space we can see from Earth, and the part that we can see is called the observable universe. The observable universe does have an edge, but it's not a border in space, it's a border in time. When we look out into space, we see the stars and galaxies from the past. And the deeper into the universe we look, the farther back in time we see. So join me on this mind-bending trip back in time to the very beginning of the universe. It seems pretty weird that our telescopes look into the past, but it all has to do with how light travels. Take the sun, for example. It's located about 150 million kilometers from Earth, and light travels at 300,000 kilometers per second. So, if you look outside, the light that you see was emitted from the sun 8 minutes ago. Yeah, the further an object is from Earth, the longer it takes for its light to reach you. And that's why when we look into space, we're looking backward in time. Just how far back in time is that observable edge? Well, using the Hubble Space Telescope, we've been able to look back 13 billion years. Yeah, we can see what the universe looked like a mere 400 to 800 million years after the Big Bang. But enough about telescopes. Let's start teleporting. Our first stop would be 19 billion light years away. At this point, the visible universe would be 3 billion years old. The Earth wouldn't exist yet, but stars would be bursting into existence. they would be forming 20 to 30 times faster than they are today. And there would be vast amounts of radiation as active supermassive black holes feasted on the surrounding matter. Okay, next, we teleport to a visible point 27 billion light years away. The universe would be 1 billion years old. Here, fewer stars would be forming. Heavy elements would be rare at this point in time, so there would be no rocky, Earth-like planets yet. Galaxies would be less developed and filled with young stars, and everything would be bathed in a hot, cosmic microwave background. We'd reach the first edge when the universe is 700 to 800 million years old. This is called the edge of transparency. At this stage, the universe would be filled with hot, opaque, glowing gas. Only infrared telescopes can see past the edge of transparency. The second edge we would reach is 31 billion light years away from Earth, and it's called the Age of Reionization. The universe would be 550 million years old. The gas that we encountered before would be gone, and the universe would be mostly transparent. The most distant galaxy ever observed is 32 billion light years from Earth. There, the universe would only be 400 million years old. That is the farthest our telescopes can see, but there are indirect signs that stars formed earlier, giving us a view deeper into space and time. If we teleported to a time when the universe was only 50 to 100 million years old, you'd see the very first stars forming. Before this, the universe was dark. But if we went further back into time, you'd witness another visible edge. At the young age of 3 million years old, the universe would be bathed in radiation so hot you could see it with your naked eye. It would be like a red glow. And the furthest point we'd teleport to would be 46 billion light years away. This would be the last and most significant edge of the universe, the ultra-energetic stage of the Big Bang. We call this an edge because we can't see further than this point, but it's not the physical edge of the universe. So, is there a solid edge out there that you could peek over? No, and here's why. The universe is constantly expanding, but it's not expanding into anything. It's more like the surface of a ball. If you walked along the surface of a giant ball, you'd end up where you started, but you'd never encounter a physical edge.
They're massive and extremely dense. They rip apart anything and everything that gets close to them. We can't see black holes, but we know they have the destructive power to wipe everything out of existence. This is What If, and here's what would happen if a black hole deleted the universe. Before we get to the part where a black hole erases the universe, let's make something clear. The universe is a giant supercomputer processing information. Without information, there can be no universe. But what is information? In physics, information is the property of a specific state of a particle. I know, it sounds confusing. Here's a simpler way of looking at it. This is a carbon atom. A bunch of these can be arranged to make a hard diamond. But if you change the arrangement of atoms, you can get soft graphite. The basic building blocks are the same, it's information that makes them different. In quantum mechanics, information is like energy. It can't disappear into nothingness. So how, in the universe, can one black hole do the impossible? That's the black hole information paradox. Black holes act like monstrous cosmic trash compactors. They squeeze stars, planets, and unfortunate astronauts who cross the event horizon into a microscopic point. So, what happens to the information about every particle that a black hole consumes? Since information can never be destroyed, it has to be stored somewhere inside that black hole, right? Our original understanding of black holes assumed that everything that disappeared in the black hole stayed in the black hole. The moment an object passed the event horizon, it got crushed into the density of the black hole. The information about it could never be retrieved again. That's what we thought before Stephen Hawking introduced Hawking radiation. Hawking realized that black holes aren't static. Rather, they release their mass and energy back into the universe, particle by particle, until there's nothing left. So, does that mean the information within a black hole can somehow escape with the black hole's outgoing radiation? Not quite. The black hole doesn't preserve the information it consumes, it chaotically mixes it together with other bits of information, making it impossible to recover. The information is lost forever. If the information can be lost, that would mean that black holes can eventually delete the universe. Forever. But there is a possibility that the black hole doesn't delete the information. It may be hiding it in a baby universe, a small, self-contained part of the universe that branched off of ours. The information wouldn't technically be lost, but we wouldn't be able to interact with it. Another possibility is that black holes can encode the information, according to the holographic principle. If you were to get trapped inside a black hole, you'd still experience three-dimensional space. For us, looking at you from the outside, you'd appear stretched on the flat surface, just like a hologram. That would mean that the information paradox is resolved, and we don't need to rewrite the laws of physics. But we'd have to rethink our understanding of reality. The universe could be a three-dimensional image projected off a two-dimensional surface. And you may be a hologram on the surface of a black hole. And the best part? The black hole couldn't delete the universe after all.
If the universe is full of stars, why doesn't it appear white? And if it did, what would it look like? Would all the black holes suddenly become visible? And if our sky was all white, would we still be able to see the stars? This is What If, and here's what would happen if the universe was white instead of black. Let me break something to you. Black is not a color, as far as physics is concerned. By definition, color is the visible spectrum of light waves. A black object absorbs all the colors in the spectrum, making black an absence of any color. On the other hand, white is a mixture of all colors, and it contains all wavelengths of visible light. Color is about our sensory perception of the world. But going back to the background of the universe, you could say it was white once. When the universe was born from the Big Bang, it didn't have any stars to emit light. It was opaque with a hot soup of protons, electrons, and neutrons. After about 300,000 years, space cooled down and those particles began pairing up into atoms and molecules. The universe became transparent. But to you, it would appear absolutely dark because not a single light source had formed yet. This was the era of cosmic dark ages. It ended when the first stars started fusing hydrogen into helium. Those stars were up to 300 times more massive than our sun and 1,000,000 times brighter. They shined for a few million years before they exploded as supernovas. The growing radiation from those first stars ionized hydrogen atoms, split them back into protons and electrons. And that's when the dark universe lit up, filled with ultraviolet protons. So why didn't it stay that way? Why, with all the new stars and new galaxies, is our night sky no longer bright? Well, that is Olber's paradox. You see, if the universe appeared to be white instead of black, it would mean that it's infinitely old, infinitely big, and static at the same time. That would make it a different universe altogether. We know that our universe is just under 14 billion years old. That might seem like a long time, but remember, even light has its speed limit. We can only see stars that are less than 14 billion light years away from us. The light from more distant stars hasn't had the time to reach Earth yet. As our universe keeps expanding, the distance between stars is increasing too. And as distant stars move further away from us, the wavelength of their light increases and shifts towards red until it becomes so long that the human eye can't see it anymore. That's another reason for the black background of the universe. Space is filled with all kinds of radiation. You just can't see it. And what about the black holes? Well, even if a very powerful source of light illuminated our universe, you still wouldn't see any black holes. Those things have such a strong gravity that they don't emit any light, and therefore can never be visible. Black is, after all, an absence of color. It would be cool to catch a black hole one day and turn it into an infinite energy source, but that's a story for another What If. Welcome back to What If. Today we'll be busting through the BS and sorting out the truth behind some of the biggest misconceptions and myths you've ever heard. We've got 3 stories that'll make you question everything you thought you knew about space, dinosaurs, and the universe itself.